Hi everyone, Tyler Roebuck with Jayco Technical Training. Today we're here with the Entegra Coach Centurion, currently the largest model that we make here at the Jayco family of companies. We're going to walk through the 12-volt DC system. So follow me along as I show you how this system works. We're going to start off our discussion of the 12-volt system, like you should in most places, here at our house batteries. So down here we've got our 4 house batteries. They're wired up in parallel and series combined. For a total of 12 volts at 440 amps. Right now our supplier for them is Crown Batteries. These guys provide plenty of juice for about any of your use cases that you're going to need. Now up on top here we've got our AGMs that are the chassis batteries, and we do use those for a couple of different things throughout the unit. Back behind, which you can't see now but I'll throw in some B-roll for you guys, we've got 2 small breakers up there. One is just a chassis power disconnect, just to straight separate the batteries from any load that they'll have. The other one is the battery merger. The batteries power our lovely 12-volt distribution bay in here. Our electrical engineers worked very much from the principle that if a component needs to be accessed, needs to be done, have something done to it at any point during its life, it needs to be visible and accessible with both hands. So you can see in this layout here, they've done a really nice job of making everything nicely clear, labeled, and accessible so you can reach it and do what you need to do. So we'll start out down here at our main battery disconnect. This is a true battery disconnect for the house batteries. If it's in the off position, those batteries are disconnected from every electrical load. If we turn it on, that will allow the batteries to power any loads that are connected. And the first place those battery loads go is to these 4 breakers right here. Hope you don't mind, I've got a little cheat sheet. Those 4 breakers are for the battery merge. So again, I talked about the battery merge on the chassis side having a breaker. This 120 amp breaker right here is for the house side of that. Our next breaker, this one over here, is for our house power. That goes to our house power solenoid, our salesman switch, our house disconnect. The next one over goes to the hydraulic leveling system. So that's just the power so that we can level the unit with the hydraulic. And then this last one over here is the power to the generator to get it started and get power going that way. The house loads coming off our breakers here go up to a couple of our different fuse blocks that you see up here. On the left, we've got our constant circuits. So these are going to be any circuits that need to be powered so long as the battery has power. There's no switch to turn them on. If the battery's got juice, so do these. That's generally for things that are safety oriented, like our carbon monoxide detector, our aqua hot so that we can run it when we need to, our patio awning controllers, things that are essential for the safety of the unit. Our battery disconnect switches over here is power provided for anything in the unit that is turned on when you press the main power switch inside the entry door. The circuits up top here on these 2 fuse panels are going to be powered off of our chassis battery. So the ones on the left are our constants. As long as the chassis batteries have power, those are going to be receiving power as well. Worth noting on our constant fuse block up here, the entry step is tied into our chassis fuse block, meaning that in order for the entry step to operate, you've got to have some juice on that chassis battery. On the other side here, we've got our chassis ignition circuits. We use this exclusively to send signal to a couple of different things in our multiplex. One, letting it know that it's got how much battery power it has and that ignition is on, and to lock out the awnings in the case of ignition being present. On our left here, we have a series of breakers. Some of them are auto reset, some of them are manual reset. You're just going to have to consult the paperwork on which ones they are. But for those breakers, we've got, from the top down, we've got our water pump, our TV slide out motor, our mid-bath multiplex, and our bed slide control modules, our rear toilet macerator, mid-toilet macerator, tank macerator, and the last one, the bottom one here, powers up our G12 up top. This is kind of the logic controller for our Firefly system. It's the brain, the computer that controls everything the multiplex system does. Underneath, we've got our battery disconnect solenoid. Our main power switch inside the door is a switch for this solenoid. It provides power to our loads, again, that are on our battery circuit. And in the corner here, we've got our Victron Cyrix. This is acting as a battery isolation monitor, where it is watching both the house and the chassis batteries. Once it sees certain parameters, it will latch the two battery banks together to charge them up. We also got a row of relays up top here, which are labeled R1 through R8. Those relays power our marker lights, badge lights, trailer backup lights, trailer charge, tank macerator, entry door lock and unlock, porch light, and our chassis ignition fuse panel. That one actually comes off this bigger breaker up here. Over here on the right, we've got our solar controller that takes any of our incoming power from the roof and sends it through a couple of different high amp fuses before it connects to the chassis and the house batteries. So back behind that distribution bay where we were just looking now is where we've got a couple of key components. Here we've got our inverter charger. So in our Centurion unit here, we have a combination inverter converter. It's provided by Victron Energy as our multi+2. So its job is simultaneously to take shore power if we have shore power present and charge the batteries with it, or if the batteries are charged up and we don't have shore power, it will invert power and provide for the unit for things like our fridge, for our household outlets, things that keep the users nice and comfortable inside. So this inverter charger is kind of the heart of both of our electrical systems where they cross over. Back behind it here, you can barely see it, but we've got a smart shunt installed as part of the Victron system as well. So that smart shunt monitors in real time any sort of battery usage that we have going on in the Victron system. So it monitors how much draw we're pulling using our house systems. It monitors how much charge is being provided. All of those things simultaneously in real time, and it is far more accurate than just slapping a monitor on the positive post of your battery. It's actively recording all of this current as it's passing through. Here as well, we've got our disconnect. We have just a firm disconnect for our solar system. So for our solar controller, this guy will disconnect any power going into our solar controller, which we saw on the other side. Down here as well, we've got our Starlink. So we've got a router right here that takes our internet and provides it, and then we've got a power supply to the dish, which is up on the roof. These guys allow our customers, if they are hooked up to Starlink, if they've got an account to Starlink, they can access the internet anywhere from around the world.